Scan the QR code or visit bit.do/quizy08 for interactive quiz. Understand. 1. State all the components in mathematical modeling. Mastery 2. A scientist is studying the cooling patterns of a particular material over time. His research requires heating a sample of the material up to 200 degrees Celsius. Then, he records the temperature of the sample as it is cooled to room temperature. The following table shows the data collected during the FRST 2 minutes of the cooling process. Time, S, 0, 40, 80, 120. Temperature, degrees C, 200,140,175. The diagram below shows 3 possible models for the data: a linear model, a quadratic model, and an exponential model. Temperature, degrees C, T time, S. 0, 50. Minus 50. 100. 50 trillion, 100 billion, 150 million, 200,000, 250. T. 150, 200. A. B. C. A. Which among the graphs of A, B, and C is a linear model, a quadratic model, and an exponential model? B. Which among the models of A, B, and C best describes the temperature of the sample for the range of times 0? T. 250? Explain why the other models do not very well for the range of times given. 3. As altitude increases, the temperature usually decreases. On average, the rate at which the temperature changes with height in the troposphere, the FRST layer of the Earth's atmosphere, is 6.5 degrees Celsius per 1000 m. The diagram below shows the cross-section of Mount Kinabalu, 4095 m, in Sabah with various temperatures at different altitudes. The temperature at an altitude of 0 m, sea level, is 30 degrees Celsius. 1000 m equals 23.5 degrees Celsius. 2000 m equals 17 degrees Celsius. 3000 m equals 10.5 degrees Celsius. 0 m altitude, sea level, equals 30 degrees Celsius. A. Write an equation that expresses the temperature, 7 degrees Celsius, as a function of the altitude, xm, for the situation shown in the diagram above. KPM 243. Chapter 8 Mathematical Modeling. Chapter 8. B. 9. Verify that your equation in A is reasonable by using the data provided in the diagram. C. Draw a graph that shows the relationship between x and 7. Show a clearly definite scale on each axis and label your axes. D. What is a reasonable range for the function 7x? Justify your answer. E. What is the gradient of the graph drawn? What is the meaning of the gradient of the graph in terms of temperature and altitude? F. What is the y-intercept of the graph drawn? What is the meaning of the y-intercept in terms of temperature and altitude? G. Is it reasonable to assume that temperature always decreases at a linear rate as altitude increases? Explain your answer. Challenge. 4. The diagram on the right shows a suspension bridge. The shortest distance from the main cables to the deck is 5 m. Show how an engineer can use the information given to solve the following problems through mathematical modeling. A. Determine the function that represents the arc of the main cable. B. If the suspender cables are 20 m apart, determine the number of suspender cables needed on both sides of the bridge. C. Determine the type of material that should be used to make the suspender cables such that the total cost of the cables is minimum. Minimum. Distance between the suspender cables, m. Type of material cost per m, Rm. Total cost of the suspender cables, Rm. 15 is 750. 20 B 1000. 25 C1 200. Exploring mathematics. Your class is organizing an end of the school year party. You are